9 symptoms of a bad negative battery cable go unnoticed by most drivers, and one of them can leave you stranded even with a brand new battery sitting under the hood. That negative cable, sometimes called the ground strap, completes the electrical circuit for every major system in your vehicle. And when it stops doing that job correctly, problems start stacking up fast. Your starter, lighting system, computers, and charging system all depend on this single cable. Yet it rarely gets any attention during routine maintenance. Weak grounding sends owners chasing after batteries, starters, and alternators because those parts look like they're failing. And here's the thing. The actual culprit is usually a corroded or damaged ground cable that costs less than $50. Money gets wasted, unnecessary repairs pile up, and the same breakdowns keep returning until someone finally addresses what's really going on with the ground. Catching these symptoms early breaks that expensive cycle before it drains your wallet. Slow cranking, or a complete no-start condition, ranks as the most common sign. Plenty of people head down the wrong diagnostic path from here. Starting an engine demands a massive amount of current, with most starters pulling over 100 amps and some requiring between 300 and 400 amps during cranking. All of that current leaves through the positive cable and returns through the negative, which means even small resistance in the ground chokes power flow almost immediately. What you typically hear is rapid clicking or tapping from the starter solenoid engaging and disengaging as voltage keeps dropping. And that sound convinces drivers the battery is dead or the starter has failed. Parts get swapped out, but the problem returns because nobody touched the ground cable. Random starting failures appear early on, working fine one day and failing the next. And that's when the starting problems become more frequent until the engine refuses to turn at all. Lighting issues tend to follow, and they become especially noticeable once the sun goes down. Headlights appearing dimmer than usual or flickering while driving often trace back to the ground circuit, causing resistance in the return path. Current flows to the bulbs through the positive side, but it has to travel back through the ground, and resistance along that path cuts usable power reaching the lights. Loose connections typically cause flickering over bumps or uneven roads, while corrosion inside the cable or at the terminals produces steady dimming that never gets better. Taillights, brake lights, and interior lights all rely on the same return path too. Reduced lighting creates more than inconvenience because visibility and safety take a direct hit, especially in low light conditions. Electrical accessories behaving strangely can make everything more confusing. Power windows might crawl slowly or stop partway through their travel. Radios cut out without warning. Air conditioning controls respond when they feel like it, and dashboard buttons act unreliable at random times. Tracing these problems back to a single cause gets difficult because they appear and disappear on their own schedule. Running headlights, climate control, and audio together places higher demand on the ground circuit, and that's when the pattern becomes clearer. Systems begin failing simultaneously when the ground cannot handle that load, creating the impression of widespread electrical problems when one weak connection sits at the center of all of it. Dashboard warning lights add another layer of frustration to the whole situation. Modern vehicles rely on constant voltage monitoring, and unstable grounding causes sensors to send irregular signals straight to the computer. Battery warning lights frequently illuminate first because the charging system cannot complete its circuit correctly, even when the alternator itself works fine. Check engine lights appear in many cases too, triggered by erratic sensor readings or communication faults between modules. Drivers ignore these warnings at first because they turn on briefly and disappear. But here's what happens as corrosion or damage progresses. The warnings stay on permanently. One of the most expensive symptoms when misdiagnosed is a battery refusing to hold a charge. Current needs to flow from the alternator to the battery and back through the ground cable for charging to work, and a faulty ground prevents that loop from completing. Slow drainage happens even though the alternator produces normal output. leading to repeated dead batteries that make no sense. Owners replace the battery first, then swap out the alternator when the new battery fails, only to watch the same issue return weeks later. A ground cable costing between $10 and $50 prevented proper charging the entire time, quietly undoing every other repair without anyone noticing. Engine stalling raises serious safety concerns and feels completely unpredictable when it happens. Unstable voltage reaching the engine control module and ignition system interrupts operation without any warning, and poor grounding sits behind that instability. Shutoffs might occur while driving, while idling at a stoplight, or during low-speed maneuvers in parking lots. What makes this symptom so alarming is the inconsistency, with the vehicle running perfectly for days or weeks before stalling multiple times in a short period. That erratic pattern points directly to an electrical ground problem rather than anything mechanical failing inside the engine. Grounding issues affect engine performance in subtler ways too. Resistance in the ground path creates voltage offsets that confuse fuel trim calculations. And the result is an engine computer commanding mixtures that run too lean or too rich. Ignition timing grows inconsistent, causing misfires that show up as rough idle, hesitation during acceleration, or stumbling under load when you need power most. Catalytic converter damage can follow over time, turning what started as a simple electrical issue into a repair costing hundreds or thousands of dollars more than fixing the ground would have. Problems with computers and control modules show up more frequently in modern vehicles because voltage stability matters so much to these systems. Engine control units typically need around 12.6 volts to operate correctly, and even small fluctuations from poor grounding lead to erratic behavior across multiple systems. False trouble codes appear out of nowhere, fuel and air calculations lose accuracy, and transmission shift quality suffers in automatic vehicles because the transmission control module gets affected as well. Separate ground systems handle high current components and low current sensor circuits in modern vehicles, which means even slight resistance in sensor grounds can distort readings and trigger issues you never expected to see connected. Testing with a multimeter usually confirms the diagnosis when you know what numbers to look for. A healthy battery at rest should measure around 12.6 volts, while anything below 11.5 volts indicates insufficient power delivery happening somewhere in the system. Voltage drop testing under load provides the clearest evidence, with the total ground circuit showing no more than 0.3 volts during cranking and the cable itself staying under 0.2 volts. Individual connection points should read close to zero, with 5 to 10 millivolts considered normal, and anything over 100 millivolts points to corrosion, or a failing connection that needs attention right away. Ground cables fail for predictable reasons, and corrosion tops that list every time. Hydrogen gas released by the battery reacts with moisture and air, forming white, blue, or green deposits that eat away at terminals and internal strands month after month. Road salt accelerates this process in colder climates, while ocean air does the same damage along coastal regions where humidity stays high. Braided ground straps trap moisture internally, allowing corrosion to progress where nobody can see it happening, which makes them especially vulnerable. Unsecured cables rubbing against engine components cause physical damage, and rodents chewing through wiring while nesting in engine bays during colder months creates another failure point entirely. Age compounds everything as insulation grows brittle and cracks, exposing bare wire to whatever the elements throw at it. Replacement costs stay low compared to the cascade of problems a failing ground cable creates. Between $10 and $50 covers a do-it-yourself repair that takes about 30 minutes to an hour. Independent shops typically charge between $100 and $225 for parts and labor combined, while dealership repairs range from $180 to well over $700 depending on access and cable routing in your specific vehicle. Most vehicles with accessible battery locations make this a straightforward job, as long as the negative cable gets disconnected first and reconnected last to avoid any sparks or shorts. Those 9 symptoms explain why ground problems get misdiagnosed more often than almost any other electrical issue. Batteries, starters, and alternators get replaced repeatedly, while one cable continues causing the same failures underneath everything else, and nobody thinks to check it. Electrical problems that seem unrelated, symptoms coming and going without warning, and new parts failing to solve old issues all deserve a close inspection of the ground cable before anything else gets replaced. Clean terminals, tight connections, and a proper voltage drop test prevent breakdowns and unnecessary expenses, because the ground circuit supports everything else running in your vehicle's electrical system.